My name is Peter Ferns. I'm with Goldman Sachs. I'm actually one of the technology fellows in the firm, and I think I'm probably one of the only engineers that's actually asked to speak today, which is probably good, I'm not sure. I'm actually in the enterprise platforms team, and as part of the technology division, as I mentioned. Basically, the teams that I manage are responsible for building the analytics platforms for the firm. So we are not actually data scientists per se. We are actually engineers that are building the platforms. Our customers within the firm are data analysts, data scientists. They're great customers, very patient and understanding. When IDSS actually originally approached me, they asked me if I would spend some time talking about systemic risk. And the first thing I thought about was, what do I know about systemic risk? And I really don't know much, to be honest with you. Although there's a line item in my resume I don't usually brag about or talk about in public much, was in the mid-1990s, I was with Lehman Brothers, and I actually built the whole loan mortgage system at Lehman Brothers. So it's not my fault. I was trying to find a good analogy for it, but I'll leave that one alone. And I'll probably circle back to that as we go forward here. How do I switch this? Forward. There we go. This is the only slide I have. I decided I was just going to talk about basically the data architecture in the firm, basically what we're working on right now. At the foundation of our data strategy really is an enterprise data lake that we've developed. Basically, all data that goes into the data lake is registered, it's managed, it's governed. Before I even get into that, actually, let me just talk a little bit about the scope of data. A couple of folks have asked me about how much data is data. It's a lot. I think someone earlier mentioned that hundreds of millions of transactions a day typically flow through a bank like Goldman Sachs. We usually see about 250 million orders and executions in our US equity space every day. We see tens of millions of trades, tens of thousands of payments and receipts into and out of the firm. And as far as e-communication data goes, it's about 6 million that run through into and out of our network every day, about 6 million e-communications like email, instant messaging, social media posts, and so forth. And of course, that's big payload data. And then you have billions, if you will, of market data. Anybody who's familiar with market data. Small payload, but very, very high volume, high transaction. The role of data steward. So every piece of data that gets put into the data lake has a data steward that's responsible for the governance of that data, the producer of that data. They usually are the producers of that data, and then we have consumers who are the other actors in the picture. They are also required to register it into a registry that we built. We call it DELP. It's like Yelp for data. It's an awful name. We're not very good at naming things. But basically, all data sets are registered, and then they become the authoritative data set for that in the firm. And historically, this doesn't sound revolutionary, but historically, a lot of these firms, like Goldman Sachs, grew up really in silos, and the data was not managed or governed as well as it should have been up till now. So it's ingested into the lake, it's validated, persisted, and secured in basically its native form. I'll try to run through this relatively quickly because I want to get to the platforms side of it with only 6 minutes. Oh, okay. All data in the lake is modeled. And modeled in this case, I'm not talking about statistical models, I'm talking about object models. So basically there's a UML-like model that's associated with every piece of data that's put into the lake. We have a strong culture of modeling in the firm. We've built our own modeling framework. It's called Pure. It's basically an ORM. You create a model that's pretty much like a UML model. It has its own language. You create a mapping of that model to the source data, and there is an execution engine that runs on top of it. We call it Pure QL, that allows you to basically query the data. It creates, materializes that model into memory, then hydrates that model and makes it available to the downstream systems. Refiners are basically infrastructure that we built, and there's a collection of APIs that allow development teams to create what we call a refiner, which is really just grabbing data, merging data, and moving it to downstream systems so that you can run analytics on it. And technical operations, we spend an inordinate amount of time making sure that we can handle all the data, that it has the right quality, has the right volumes, that it's complete, and so forth. I have a small team that built a thing called a data monitor. I told you we're bad at naming things. But basically, it just keeps track of making sure that all the data from the source makes it to the endpoint. The analytics platforms I was going to touch on were two: text analytics and graph analytics. In text analytics, as some folks talked about unstructured data and text analytics, these platforms were born out of compliance technology, which is where I spent 12 years. And I ended in Goldman Sachs as a CTO of compliance technology. Basically, the original one was built for e-communication compliance, pulling in emails, instant messages, and trying to ensure that we're compliant with all the policies and regulations. So basically, there's two pieces to the text analytics platform. We call it a text refinery. It's not actually just a refiner, but it's a set of processes, a pipeline of processes that run on the data. We extract the text, which is actually a very hard problem. It's often overlooked, is basically just getting the text into text format. So Word documents, PowerPoint, so on and so forth. How do you actually extract that text and get into text format? Entity extraction, so you pull out people's, places, things. Assertion extraction, John traded IBM, for example, is an assertion. And then categorization is saying, okay, this entity is a person or a government agency, or in our case, we wrote some custom analytics that run on top of it. They'll say, it looks like it's a trade or a transaction or something of that nature, or it's a product. It's a ISIN or a QSIP, or it's a product identifier. And then co-reference is when, in this part of the document, my name is mentioned, the other part of the document, it says him, it's the same person, and basically that we understand it's the same person. And those are done on specific messages, specific transactions. And then use cases, well, I'll skip over that for a moment. Advanced analytics is basically looking then across the entire data set and doing much of the same as I just mentioned, right? So then we basically can pull together entities across data sets and create concepts and build on those concepts and assign confidence levels to them and so forth. And what we call knowledge objects, which is really just more data about those concepts, interconnections between other concepts, and how they relate to one another. And again, confidence levels associated with them. That data is all then persisted back into the data lake, and it's made available to the analytics teams if they want to pull it and run their own custom analytics on top of it. Graph analytics, this is something that is very near and dear to my heart. When in compliance technology, we built a big graph. Basically, when you looked at all the different compliance problems that we've seen, it was interconnections. Basically, every problem that we saw pretty much had a social network of some kind associated with it. When I say social network, a lot of times it is people, but usually the core concepts are people and entities. Almost every problem that you see has a person and an entity associated with it, and understanding the connections between them is extremely valuable. So we build a big graph. The big graph is about 2 billion nodes and edges, and some of the components for building it are basically, again, making sure the data is modeled correctly, and then we built a rules engine that runs on top of that model that basically pulls together and associates the rules. So for example, I might, myself and say Devrot sit near each other, right, would be a rule that we would run on top of it because our desks are located, say, 10 meters apart. So one of the areas where we do use graph analytics in surveillances is, let's say, in insider trading. So the trader traded a certain security. This is the security. This is the entity that that security belongs to. Who within the firm, let's say, has confidential information about that entity? So who's the research analyst, who sits on the sales desk, and so forth. And then we can query the graph and find the connection between them. We call that relationship risk, and that returns back to the surveillance to say, yes, this may have a higher level of confidence that this could be a risky transaction. So with that, that's pretty much all I have. A lot of what we talked about today, if you think about it, was how do you understand the interconnections between the different systems? I mean, even in the beginning of the day, I think it was Duran who mentioned interconnected networks and understanding the weaknesses between the interconnections and so forth. Some of the other folks talked about social networks and how they're connected, or how they basically apply to risk. I don't think the graph is the only answer, but I think it definitely should be part of your data strategy. That's it.
So they're very interesting and clearly hard problems. In this space, once you've done some analytics and you've reached some conclusion, as these methods get ever more complex, it's hard to back out the reason for the conclusion. So you reach the conclusion, it appears that someone has done something they shouldn't in this complex network of 2 billion nodes. Can you back it out to an explanation that someone understands?
That's a good question. So first disclaimers, I'm not a compliance officer. I'm a compliance technology provider. Yeah, I mean, we do keep lineage on the data that first of all, the data that comes in and how we track it and make sure that we know what it was. One of the questions you're asking is actually something that I'm spending a lot of time on right now is what types of queries are being run against this data? Because in the analytics world, these are not always production systems that are well known and are basically are in production and the queries are predictable. You have data scientists who are running a lot of ad hoc queries against this data, pulling it back. So we're building a ton of technical controls, building and trying to leverage some market software that basically can track every query that's put into the system and how it comes back. One of the things we're wrestling a lot with is, do you actually save the data set that comes back, or do you just save the query and then recreate the data set later? So that's some of what we're doing. But those are more usually on the technical control end as opposed to for the data scientists themselves.
Audience, questions? Yeah. In the back? Someone got a microphone to hand out?
Thanks for that talk. That was a really amazing insight into compliance technology. A little bit frightening. I'm curious, do you think that's a cutting-edge proprietary technology, or do you think this kind of text mining for compliance is going to become much wider spread in finance or the rest of society?
I think it already is becoming much wider spread. I mean, 5-6 years ago, in the e-communication space, basically it was check the box. You have to review, I think it's 1% of e-communications that flow through your firm every day. It's a regulation. If you read the Wall Street Journal or any of the newspapers, you've probably seen that there was a lot of issues, especially in Goldman Sachs, where emails were surfaced by and sent to regulators and so forth, and even wound up in front of the Senate where Lloyd Blankfein sat in front of a Senate panel and they waved emails in his face, and ever since that day my life has never been the same. So we got very, very serious about text analytics really at that point, and a lot of what we're doing is focused around that. I do know a lot of the other firms are doing much the same, but I got to tell you that in text, in emails, instant messages, and so forth, it's an absolute treasure trove of information. If you think about, I bet you almost everybody in this room goes to work in the morning, logs in, goes to their email, and starts typing what they're doing, right? That's all in there. We rarely use that in the financial industry. And basically what my role has been was to take that same technology that was used in compliance and platformize it, if you will, for the firm, and leverage it in other businesses. So we're using it now in customer relationship management, of course, information security. We're using it in human resources. So much of that technology is now more pervasive.
So we can assume there will be no Goldman Sachs papers in the paper next week.
I wish I could say that.
So Tim Baker, Thomson Reuters. So the first thing, Peter, we completely agree with the graph vision. We'd love to connect our graph with your graph at some point. We've got billions of connections too. What are the biggest challenges you see in the graph space around connecting your very rich internal private data with the kind of outside world, like, for example, all those people mentioned in the Panama releases over the weekend?
There's a ton of challenges with it. I won't even talk about the compliance and legal challenges, because trying to get approval to do anything like that is out of my control. Understanding entity resolution is extremely difficult, right? The data that we have in the firm, typically we know, right? We know our employees, we know it's their email, either they're a sender or a recipient of it, so you have an anchor point of that data. Similar with structured data, right? You have an anchor point, you know what product ID it is, or you know what transaction ID it is. But when you start to pull in unstructured data off the web or from Thomson Reuters, usually, you'd have to basically do your best guess at what that entity is. Right, so it may come in and say international business machines. Is it really the international business machines that we have in our entity master database? We're not sure about that. So we have a ton of analytics that run that try to make their best guess to kind of marry that data together. We have approached that subject of actually creating this knowledge graph for the financial industries. There's been discussions between some of the different firms about it. Usually it's the compliance issues that stop that from going forward. It's also, I think, a very difficult deal to make, but technically we've thought a lot about it. We believe it's feasible. It's definitely technically feasible. I think if you can get past the compliance issues with it and the legal issues with it, it's technically doable.
So I think we need to move on. Thank you.
Okay.